All right, trophoblast. Can you see my arrow here?
It's that pink and red stuff in the middle.
It's, watch this, I'll trace it here. It's this layer of cells right there. You see that? The very outer layer of cells in that early embryo. If you look right here, this part of the embryo, actually the future baby, is just this 2 layers of cells right there. So when you were this far along in your embryo development, remember that? When you were this far along, you were just 2 layers of cells, kind of like 2 pancakes on top of one another. Okay? And there's your yolk sac. There's the amniotic sac. It's not very big yet. Okay? Eventually, you know, that's going to totally envelope the entire baby, right? The amniotic sac. This part right here is about the size of a poppy seed. This part. How many of you guys, any of you guys had the etymology course? Okay, you know what troph means?
Nope. It's been 2 years.
Oh, you've slept since then.
Isn't it nourishment?
Yeah, it has to do with nourishment. Troph. Like when you guys took biology as 9th graders, you probably learned about the trophic levels in ecology. Troph refers to nourishment or eating. And so, anybody want to take a guess as to what the trophoblast layer of cells, what it's responsible for?
Control nourishment.
Nourishment. Here's what happens. Out of the trophoblast layer, you're going to have these finger-like projections of cells that start growing into the lining of the uterus. They're called chorionic villi. Does that ring a bell?
Yep.
Chorionic villi. They start growing and dividing, rapid mitosis, invading the lining of mama's uterus, and they attach the embryo to the lining of the uterus. And then those chorionic villi, they start to tap into mom's blood supply so that the embryo, the early embryo, can start gaining nourishment, nutrients, and oxygen directly from mom's bloodstream. That's what they do. Chorionic villi. They also, it's kind of interesting, they start to produce a hormone, a chemical that tells the uterus, do not shed your extra lining and blood supply. Do not menstruate. We've got a baby in here right now. That's what the chorionic villi also do. And then later on, they develop into the placenta. Remember the placenta? That fancy organ that helps gain access to mom's nutrients and oxygen during the whole rest of the pregnancy.
What would happen if the woman did menstruate while that thing was in there?
Then that early embryo, no, that's a good question. It's a good question. That early embryo would be lost. It's only the size of the poppy. It would be lost. Early miscarriage. Early miscarriage. Now, I used to think a miscarriage was not a big deal until it happened to me and my wife. And then I learned it is a big deal, you know. Now we were like 2 months along, but at this very, very early stage, we're looking at what, only 10 days. 10 days after fertilization. If this embryo is lost 10 days after fertilization, mom might not even realize she was pregnant. Might not. She might know. But then there's a good chance she might not know either. I read a case once where a young woman went the entire pregnancy not knowing she was pregnant. Now, that's really rare for something like that to happen, but you know, anything's possible. I've learned that in human genetics, I know that sounds weird, but I've learned that in human genetics, anything that's conceivable is conceivable. Got that?
Yeah.
All right. The chorionic villi, like I said, they make a hormone that tells the uterus to maintain the extra lining and blood supply so that that baby can be maintained through the pregnancy. That hormone, by the way, then gets into mom's bloodstream and ultimately into the urine, and that's the chemical, that's the hormone that's detected in that at-home pregnancy test with the strips. That's the hormone. It's called, now this isn't on a test, so this is free of charge. It's called human chorionic gonadotropin. Human chorionic gonadotropin. It's a human hormone. And there's something else that's weird about that hormone. I remember doing it in the lab at Purdue when I was a college student. If you take human chorionic gonadotropin, believe it or not, you can order it from chemical companies.
Cool.
Human chorionic gonadotropin hormone. If you inject it into African frogs, you know, like the two little African frogs in that tank over there? No, it'll cause them to go into mating season and mate and produce
So
offspring.
it's not.
We're literally playing God.
It's a human hormone, but it will do that to those African frogs.
Why? That's the one thing it's good for.
Well, the other, for humans, it's good because it maintains the uterine lining.
Well, yeah, but like outside of the body.
I think that's the only other way they use it is
How do they
in
figure that out?
develop. I don't know.
I was literally just gonna say, how do you just be like,
Just go around and
yeah, let's
injecting
inject frogs with this stuff.
Okay, what
Some-
do you find?
I'll tell you, I think probably how it happened
Jim,
was
take the two up.
some researcher was studying embryo development, and it's easy to do with frogs like that because their eggs are big. How many of you have seen frog eggs in a pond in the springtime? They're you can see them. They're visible, okay? They're not microscopic. So they make ideal specimens if you want to learn about embryo development. And so they just started trying things and thought, well, let's try this hormone and see if it works. So evidently the the chemical structure is similar enough to hormones in other vertebrate animals that it works. Okay, what other questions you guys have about pages 2 through 9? Any other? I'm just letting you kind of drive this right here. Yeah.
Letter R on page 6.
Letter R on page 6. Okay.
Also Q.
Okay, we'll get there. Letter R, page 6. Okay. Oh, there's the answer. All right. Letter R, page 6. How many had this? Did you have this? Okay, differentiation. The gastrulation is when differentiation happens. Okay, gastrulation is when some of those cells on the outside of the embryo start to move to the inside.
So what's N?
I'm going to wait for you guys to stop. It'd be kind of rude if I interrupted. Okay, differentiation. That's when certain genes in certain cells are turned on and off, and in other nearby cells, other genes are turned on and off differently. Differentiation. And that process is still pretty much a mystery, big mystery in genetics. You know, how is it that in certain cells in the early embryo, certain genes are turned on, and that makes those cells become, let's say, skin cells, and other genes are turned on in other cells, and those cells become brain cells? You know, how's that work? Still pretty much a big mystery. differentiation. Okay. Alexis, you had another question, I think.
Yeah, I actually had someone else answer, but Q?
Q,
Oh, maybe that was the one. Yeah, Q.
Q. Okay. Q, 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 Q. O. What happens during gastrulation? Okay, here's what happens. Okay, here's your 12-day embryo. This is you 12 days after fertilization. Okay, actually a cross section. You've been cut in half here. Sorry, cut in half. This layer up here, endoderm cells. Hang on a second. Raise your hand if you think you know the answer. Doesn't mean I'm going to call on you necessarily, unless you want me to. Raise your hand if you think you know the answer. What kinds of body parts do endoderm cells become? Okay, raise your hand if you want to announce it to the rest of the world. Isaac?
Skin, hair, finger.
Yeah, outer parts. No, inner parts, I'm sorry. Endo means inside. Endoderm. You're leading me astray. Endoderm, inner parts.
Endo means in.
Your digestive system.
Your trachea and your lungs.
Excellent. Lungs, trachea, those are examples. Digestive system. The very inside parts, endoderm. Okay. This other layer of cells right down here, ectoderm. Actually, this is going to be the back of the embryo, so it's kind of upside down. Ecto, outside. Now, Isaac, this is yours. What comes from ectoderm cells?
Skin, hair, and fingernails.
There you go. Claws, antlers, the brain.
Yeah, it's in.
Brain and spinal cord. And nerves, yeah. And eyes. What? Yeah. Oh, I thought I saw a hand up. No. Okay.
Where are we still going on this week?
Yeah. Okay, we're going to get back to that. About 12 days after fertilization, right here, you see how some of these ectoderm cells, they kind of form a groove here, and they descend down into that, and they emerge and squeeze in between the existing endoderm and ectoderm layer and make a new layer of cells in the middle called mesoderm. That's called gastrulation, that process. Okay. Did those video clips in the computer tutorial make sense? Were they hard to follow, easy to follow? Or
It was iffy from one to one.
it was what?
It was iffy depending on which one it was.
Yeah.
Okay. All right.
Thank you.
Who said that? Oh, you're
One
welcome.
last question.
You're welcome. So you got that? You got these ectoderm cells squeezing down into this. It's like a crevice, and they emerge between the two layers and form a new layer sandwiched in the middle called mesoderm.
You know when people have inverse organs because of their cilia, like what stage of embryonic development would that happen when their organs are placed are inverse?
The organs are switched around?
Yes.
I don't know. That's a good question. When during that 9-month period does that happen? I don't know. That's a good one to Google. Now see, I'm going to Google that this weekend. Are you?
Probably.
Maybe. That's a good question. By the way, what kind of body parts would come from mesoderm?
Your heart and lungs.
Excellent. Heart, bones, muscles, reproductive organs. Okay. What other questions you guys have on pages 2 through 9? Chloe?
Page 2, D and E.
D and E. Page 2. Okay. We'll probably get to that. Page 2, D and E. What percentage of all fertilized eggs fail to develop? The computer tutorial said 50.
Greater than.
Yeah, greater than 50. Since I made that computer tutorial, we now know it's 2 out of 3.
So it's about 66%.
Yeah, so it's greater than 50%, but about 2 out of 3 fertilized eggs don't make it. They fail to develop for some reason. That means, okay, my mama had 5 kids. She could have possibly conceived 15 times, right? No, we don't know for sure, but. Okay, and what was the other question? E? When the first sperm enters the egg, the zona pellucida hardens and becomes a shell that blocks out all the other sperm cells. Wait a minute. What's a zona pellucida?
Outer shell of the egg.
Okay, it's the membrane around the egg. Okay, it's a soft membrane around the egg, and as soon as the first sperm enters, that triggers the zona to harden. There are some chemical reactions in that zona that occur, and it hardens like a shell. Okay, and that prevents other sperms from getting in. It's triggered by the very first sperm. Let's take a look at something here. Okay, I'm going to skip that, and skip that for now, and skip that for now. That for now, we'll get back to that. We need to look at the uterus again. We'll get to these. You know those people? Okay. So when the egg breaks out of the ovary and enters the tube, as soon as the first sperm gets in, that triggers that zona to harden, just like a shell. And so as that early embryo is moving through the fallopian tube on its way down to the uterus, it's going through these mitosis divisions. See right here, it's a 2-celled embryo, you see that? It's still inside that hard zona. 4 cells, still inside that hard zona. 8, 16, still inside that hard zona. But then before the early embryo, it happens around day 4, before it gets to the uterus, it breaks out of that zona, and that's called hatching. So you hatched on day 4. So how come we don't celebrate hatch days?
We don't know if she's pregnant.
It's hard to calculate when the actual hatch day is. Yeah. The actual birthday, that's pretty obvious. All right? Pretty obvious. But you guys hatched on day 4. And that's so that the embryo can come out of that hard shell, which protects it on its journey through the tube. That's so it can come out and attach to the lining of the uterus. Now, it says here, why is this a good thing? Why is it for that zona to harden as soon as the first sperm cell enters? Why is that important? Why is that a good thing? Why is it good to prevent other sperms from getting in? Eli?
It's from the egg transfer information. It would only be between those 2 bodies rather than a third.
Right. To have a normal embryo, you've got to have 23 chromosomes from the sperm, 23 from the egg, right? To make a new fertilized egg with 46. Sometimes, it's rare, sometimes 2 sperm cells will make a photo finish, and they'll both enter the egg at exactly the same instant. They both get in, and then the zona hardens, and then you've got 23 chromosomes from sperm A, 23 chromosomes from sperm B, 23 chromosomes from the egg, 69 chromosomes. Everything's all out of whack, that's way out of balance, and that fertilized egg dies within a day or 2. It just can't survive. So that's why it's a good thing that zona hardens. Okay, Quinn, you look like you were getting ready to ask me something. Zona. And what other kind of questions?
Yeah, I just, if you could do N on page 4 and then V. on
M?
7. Yeah, I just want to make sure I have the right answer.
Okay, M on page 4.
And then V on page.
Okay.
There you go.
All right. M on page 4. If I can find page 4.
Same.
Okay. M, page 4.
Yeah. So I guess it's a-
Ah, that's a repeat, isn't it? Differentiation, where certain cells specialize to become certain kinds of body parts because in those cells, specific genes are turned on and off.
So what's gastrulation? What is that?
Gastrulation, remember, is when those ectoderm cells squeeze in between the existing ectoderm layer and the endoderm to make a new mesoderm layer in the middle. That process is called gastrulation. Got that? Okay, what was the other question?
V on page 7.
V, page 7. All right. V. How early do the nerve cells begin to develop? Anybody get that?
Day 15.
About 2 weeks, yeah. 14 to 15 days after fertilization. That's pretty early. Nerve cells. Okay. Any other questions? T, page 6. Page 6, T. Okay, how long does it take for the neural tube to close up? About a week. About a week. Okay?
So 1 week, because I got 3 weeks after fertilization.
Okay, it starts, you're right about the 3, it starts at 3 weeks, but it finishes about a week later, okay? So here's you guys, and me, and Mr. Hoke and everybody. Here's you 21 days after fertilization. This is you. From here, from head to tail here, you were about the size of a grain of rice uncooked. That's how big you were. 3 weeks after fertilization. So what happens here is this groove, those ectoderm cells, outside cells along the back of the embryo, they start to move around and they form a groove that runs down the back of the embryo. And then a little bridge forms. Those cells are actually moving and piling up, and they make a bridge over that canal, if you want to call it that groove. And then it kind of looks like there's an invisible zipper. I mean, it's really not a zipper. That then closes the tube up in this direction and at the same time closes the tube up in that direction. And then you end up with this hollow tube running down the back. That's the neural tube. What's neural mean?
Brain.
Brain has to do with the nervous system, right? That hollow tube running down the back, see, that's going to become the brain up here, spinal cord. Here's 28 days. The tube should be totally closed up, but what the artist is showing here is that sometimes there are gaps, like the tube might not close up all the way. See the gaps? You ever have a zipper that gets stuck and doesn't close all the way?
It's my backpack.
Your backpack zipper is like that? Is it? May I see it?
Right here.
Good example of a zipper that doesn't close all the way. Oh yeah, I got a gap there.
I mean, like, it opens up.
Yeah. Yeah. Okay, that closure of that tube, we're going to actually get into polygenic inheritance next semester, but this is like a sneak preview. That closure of that tube, which takes about a week, is under the control of a whole bunch of gene pairs all working together. So that trait, closure of the tube, is called a polygenic trait. If some of those genes don't work right, you might have a gap. It doesn't close up all the way. Maybe here, maybe here, maybe here, here, there. And that gap then is set in stone. So 9 months later, when the baby's born, there's a hole in the spinal column right there. And if cerebral spinal fluid has leaked out of that during the pregnancy, that's not too much of a problem. But if the hole is big enough in the back and spinal cord tissue gets extruded through that, and spinal cord tissue can get damaged during the pregnancy, then the baby could end up paralyzed from that part down. Partial, maybe just have partial use of the legs or loss of bladder control. What are those conditions called? Who remembers?
Neural tube defect.
Okay, collectively neural tube defects. If it happens along the spine, anywhere along the spine,
Open spine.
open spine. There's another term, fancy term for it. Anybody remember? You can look at your notes. Oh
Yeah,
yeah,
that's a big one.
that's a mouthful. Okay, that is on page 7. Okay, encephalocele. Well, that's a mouthful. That's when the opening is way up here on the back of the neck. I'm going to show you a video clip that shows somebody who was born with this and turned out just fine. Surgery was able to correct it. But if the opening is way up here at the top of the spinal cord, back of the neck, it's called encephalocele. We'll look at a picture of that. If the opening is way up at the very top, anencephaly. You know what cephaly means? The word ceph or cephalic or cephaly?
Head.
Head. What's an on the front of a word mean?
Anterior, like distal spine.
Yeah, it can mean anterior. An or a on the front of a word can also mean not. So anencephaly, literally not head. Well, what happens is the top of the skull is totally open, and during the pregnancy the brain doesn't develop. Do you remember those pictures in the tutorial
Yeah.
of the newborn with anencephaly? Remember that? If they go full term, they don't survive more than an hour or 2 after birth. They just don't survive.
Does the mom know during pregnancy?
That's a good question. An early ultrasound can show that. So, now that raises, remember the bioethics discussions, that raises a bioethical question. What does a woman and her husband or partner do if they discover, let's say 4 months into the pregnancy, that the unborn baby has anencephaly? The neural tube failed to close at the very top end. Skull totally exposed during the pregnancy. Not much more development of the brain than the brain stem. Not going to survive. It's 4 months into the pregnancy. Gabby?
Is that what they call when the baby is born without a brain?
When the baby is what?
Born without, like, the, other than the brain stem, that they're only born with brain stem, that's it, when they're stage 3.
Yeah,
Born without brain.
anencephaly. Now, there's one bad part about learning about human genetics. And I've heard people say this before. They start learning this stuff and they say, I don't think I ever want to have kids. But you got to remember, 96% of the time when a baby's born, practically perfect in every way. Sounds like Mary. That is a quote from Mary Poppins.
96% of children born are
96% of the babies born are practically perfect in every way.
Miracles off the phone.
No, she didn't say that. She just said practically perfect in every way. But the 4% that have problems, fortunately, most of the time, those are very,
96%.
very mild. What's that?
96%.
96% have no problems. 4% can have some problems, but fortunately, most of the 4% are very mild. Like maybe a slight heart murmur that the child's going to outgrow. It can be pretty mild. Okay? Now, I remember a few years ago I was teaching one of those human genetics and bioethics summer courses in Chicago. Classroom full of high school biology teachers. And we actually got on the topic of neural tube defects like anencephaly, the worst kind. And the discussion got to where it was related to what you asked about, okay? The discussion was, what do you do if you find out 4 months into the pregnancy that this unborn baby has anencephaly? What do you do? What are the options? And you can imagine, there's a big discussion going on, okay? There were some people who said, oh, no question, you terminate the pregnancy. There were some people who said, no, you can't. It's not up to you to decide to do that. You know what I mean? It got to be a bioethical discussion. And there was one guy sitting in the back who never said anything, ever. He was a good old boy from Southern Illinois. He never spoke up in class, never said anything, very quiet. And I looked in the back and his lip was quivering. And he's starting to raise his hand, and I thought, uh-oh, here it comes. And when he started talking, you could have heard a pin drop in there. The whole academic discussion ended, and they listened to what he said. Oh, you could have heard a pin drop. He goes, my wife and I have 2 little boys, and when our boys were young toddlers, my wife had a little girl, and my wife and my sons and I sat there with the new baby, and she had anencephaly. And he said they had her head all bandaged up, so you couldn't see. And he said, we held her for 2 hours. We got to spend 2 hours with her before she passed. And he said she was very much our daughter. And oh my gosh, it was like, suddenly everybody's real quiet. And you just kind of learn in those situations that this is more than just stuff in a textbook, right? This is real. It gets real sometimes. So, any other questions about neural tube defects? Don't mean to bring you down, but sometimes it's real life. Real life. Did you recognize the song that I was playing when you came in here? When Mr. Preston poked his head in and said, "You guys know who that is?" You didn't know who that was, did you? John Mellencamp?
That's what you said.
Okay. They used to call him John Cougar. Where did Mr. Preston say John Mellencamp was from?
Seymour, Indiana.
Seymour, Indiana. Yeah. Seymour. Now, I want you to check this out, okay? Check this out, you guys. I think you'll find it interesting.
Rock and Roll Hall of Famer John Mellencamp is back with a new album. It's called Plain Spoken, but last month, just as he was getting ready to promote it, Mellencamp had a life-changing experience, you could say. He talked with Anthony Mason. That wasn't the life-changing experience, but he did talk with Anthony Mason about the reunion and has him looking at things. Well, let's see. You're right, Charlie. As I'm looking at things in a new light. Good morning to you, Anthony Mason.
I don't know. I think it was pretty exciting.
Yeah.
You've changed a lot of people's lives.
In the early 1950s, most babies born with spina bifida did not live long, but John Mellencamp survived after a pioneering operation. Last month, after more than 60 years, he finally met the doctor who saved him.
I am a troubled man.
Troubled Man is the lead single of John Mellencamp's new album. His troubles started right at birth.
I am a troubled man.
But for most of his 62 years, the singer knew little about the surgery he had as a newborn.
I didn't even know I had the operation until some kid, about 9 or 10, said, "What's that big scar on the back of your neck?" And I went home and asked my parents, says, "Don't worry about it. You had an operation when you were born."
Last month, at the Riley Hospital for Children in Indianapolis, Mellencamp finally met Dr. Robert Heimberger, now 97, the neurosurgeon who performed the life-saving operation in 1951.
They remember because I was the first one they'd ever done.
Spina bifida is a birth defect that causes an opening of the spinal column that can sometimes allow the spinal cord to grow or extend outside of the body. The hospital still has the records of Mellencamp's surgery. This is the back of your head.
Yeah, there's a crown on my head right there.
Including this image of 9-day-old John Mellencamp.
It's my ear, that's my neck, and that's my neck. So this thing was the size of a man's fist. You know, I'm 62 years old and I just for the first time saw the growth of the back of my neck. It was just like, why didn't you guys show this to me earlier?
Yeah.
Because I would have seen how lucky I am to even be here.
Yeah. Well, what was it like to see that for the first time?
It was like finding out that your parents weren't your parents.
Mm-hmm.
I mean, it was really an epiphany moment for me, and you know, you just couldn't thank the guy enough. And
You should be dead.
oh, sure, yeah.
In 1951, John Mellencamp was one of 3 babies at Riley with spina bifida.
They did 3 operations. One died on the table. Another girl lived, I think till she was 14, and then she died. And then me, so they basically cut my head off from ear to ear, laid it open, cut that thing off, and then put all of the nerves into my spine.
Dr. Heimberger's highly risky procedure took 18 hours.
He charged my parents $1.
$1?
Yeah, they paid $1.
Because?
Well, because I was guinea pig.
Does that change the way you see yourself in any way?
Yeah, it does.
The singer remembered walking down a New York street in the 1980s, the height of his success, when he was stopped by an older woman.
And she said, "You know how many angels you have around?" And I went, "What?" She goes, "You are covered with protection." Now looking back on her saying that, seeing what I've seen, maybe I believe it.
Well, a lot of songs on that, I would think.
Well, I think there's already been a lot of songs. I just didn't know.
Yeah.
I just didn't know where they were coming.
People up on the east side, people down Gravel Road.
Mellencamp and the doctor who saved him 62 years ago sat together for about an hour last month.
And basically, we talked about faith. And because I had very little faith in anything. He just kept grabbing my hand and saying, "John, you need to find faith."
It's so lucky you got to see him.
Trying to take his advice to heart.
You are.
Try to find faith in something.
John Mellencamp will start an 80-tape tour beginning in January. His final show in Indianapolis next summer will benefit the Riley Children's Foundation, which supports the hospital where he had that surgery back in 1951.
This is the most incredible story.
Can you imagine finding this out at
No.
62?
How did he find the doctor?
It was actually a series of coincidences that led. The doctor is living in a retirement home in Alabama, but he found him down there. He first talked to him right before he was inducted into the Rock and Roll Hall of Fame in 2008. But finally, the doctor's sons called him recently and said, if you want to actually meet him, you better do it soon. He's 97.
What a beautiful story on so many levels. I
Yeah.
look at John Cougar, and he's now John Mellencamp.
Yep.
How did that change, John Cougar, Mellencamp?
Well, actually, he was given that name by someone who signed him when he first started. He never liked it, never wanted it, and finally was able to outrun it.
Now I look at John Mellencamp differently.
I think he does too.
I want to go get some of his music. Thank you, Anthony.
Okay. That was, okay. The surgery was done, we're going to skip that. The surgery was done in 1951. And when this was filmed, he was 62. So 2015, is that 13, 2013? Something like that. So I doubt the surgeon may not still be around. Hey, good luck. Good luck. So in the video they said he was born with spina bifida, but a special kind of spina bifida, right? That's what he had right there. What was that called again?
That was the worst type.
No, he didn't have anencephaly. Anencephaly is the worst kind, where the top of the skull is open and there's no brain development.
So is that regular bifida?
He had this one, where the openings in the top of the spine at the base of the brain. Encephalocele.
So how exactly do they surgically remove that?
Well, I don't think he had everything straight. He said,
I don't think that was true.
but I don't know exactly what that surgeon did back in 1951. Remember, he said he was a guinea pig. Basically, what they do nowadays is they'll lance this and drain the fluid. And believe it or not, it can look this bad and there be no spinal cord tissue or brain tissue extruded through the opening. And they can lance it, surgically close it back up, and the baby would be okay. Sometimes it looks worse than what it really is. Gabby?
Do they try to see if there's any spinal nerves or any brain matter there by ultrasound, or how do they find that out before they just cut it off?
They use ultrasound, yeah, to check. Because if there is brain or spinal cord tissue extruded into that opening, into the cyst, they're going to have to do some different kinds of things.
So what exactly is it that comes out of that? There's like no spinal, is it cerebrospinal fluid?
It's, yeah, cerebrospinal fluid. Inside your brain, there are these like hollow spaces deep inside your brain called ventricles, and they produce fluid, cerebral spinal fluid, that moves down your spinal cord and kind of lubricates it as it goes. And that's where it comes from.
I'm a little confused. If there's gray matter in the cyst, can you survive or no?
Probably not.
Yeah.
Now, how big the opening is going to determine. The bigger the opening, the more likely there's going to be nerve tissue, like spinal tissue or brain tissue, extruded through that opening. Okay. Yeah.
So it's probably dynamic or stuff out of it.
He probably didn't have real severe nerve damage at all because
he's walking.
He's walking, and he survived. Yeah. Gabby?
So, it's the spinal cord that didn't close, not the actual hole. So, this would be outside of the skull, right?
I'm sorry, say again.
It's the spinal cord that, spinal shaft that didn't close all the way, so the spinal fluid is coming out of the shaft of the hole, right?
Yeah, now what happens is, if that neural tube way back 3 weeks after fertilization didn't close, then the muscles and bone that are kind of surrounding the spine, they don't close up then.
So the whole thing is just the gap.
Right.
And all the way to the skin.
Yes.
So are they able to just maybe put a shunt on the actual cord and then they have to like fill it? Do they just
It depends on how big the opening is, as far as how much they've got to do that kind of reconstructive surgery. It depends on how big the opening is. Several years ago, I had a girl in genetics class who was fine, but she raised her hand and she said, I was born with spina bifida occulta. Occulta means hidden. That was one of those in the study guide.
That's really minor.
It's very minor, yeah. Very tiny little open at the base of her spinal column. so tiny that when she was born, there was no hole there, no cyst or anything. And I think she had started having back problems as a teenager, and x-rays and ultrasound showed, oh my goodness, you were born with spina bifida occulta. So she was born with that. There was a pitcher in baseball years ago, major league pitcher, I remember, who was born with that. You guys don't remember him because it was before your time. His name was Ruhl. You know that name? He was a pitcher. Mr. Hope, do you know that name?
88 Dodgers World Series.
Yeah.
Yeah.
So he was born with this spina bifida occulta. So I guess the moral of the story is, even if you're born with some genetic thing, you can still grow up and do great things, right?
Yeah.
Write songs, sing songs, pitch for the Dodgers.
88 World Series.
That's right. That's right. All right. Okay. Any other questions about pages 2 through 9, human embryo development? Are there others? Bless you. All right, guess what? Whole new topic. I want to look at art, assisted reproductive technology, and they're just some basics of things that I want to look at, so that when you guys go to the art clinics, one in Chicago, one in LA, so that you'll know what you need to know in order to understand what they do and how they do it. So take your study guide and turn to page 9. You're there. All right. You guys are doing great, despite the fact that this is one of those Mr. Ruhl's talking the whole time days. I want to get you ready for those clinics, okay? Assisted reproductive technology. Actually, this starts to get kind of weird. Not really weird. We're talking about different medical techniques to help people who have trouble getting pregnant. And yeah, assisted reproductive technology. Actually, I know several people who have gone through this, and they were successful and able to have kids. A couple years ago, I had a girl in genetics class. She sat right here. Oh, and she had a twin brother. But they were both, and she shared this in class. She said, my twin brother and I were test tube babies. And so it's becoming, pretty common. It happens. Now, back in the 80s, I remember when I was young, where were you guys in like 1984?
Not even thought of it.
Not even thought of.
I was swimming in my dad.
Jeff High School.
Jeff High School. Your parents. Okay.
In Connecticut.
Anyway, I remember back in 1984 when the test tube baby technique was fairly young. It was like, wow, high tech, this is really weird, this is different, but it's becoming more and more common. Called In Vitro Fertilization. Okay, let's look at this. And the reason I want to talk about this is because when you go to the art clinics, you're going to see that a lot of the things that they do are based on this. Okay? This is like the basis of all those techniques. Anybody know what in vitro means? Who's been in med terms? Raise your hand if you've taken med terms. Or are you taking it now, or med terms? Do you know what in vitro means? They what? Okay.
I won an award for an in vitro project, and I don't know.
Oh! Did you guys know that? Emily Bryce won an award at the Science Fair last year for an in vitro project.
Yeah, like best in vitro experiment, and I was like,
Okay.
I didn't know it was in vitro. Is it like in cell?
In vitro means an experiment that's done outside the body, not in the body. In glass. like in a petri dish. So that's what in vitro fertilization means. Fertilization outside the body in a petri dish. Make sense? In vitro fertilization. Now, I remember a long, long time ago, I took this picture off the front of a Time magazine article down in the school library. Look at the date, September 10th, 1984. This is, what?
I said you've been teaching a while.
Yeah. A long time. Yeah, old am I. Okay, so yeah, 1984. So test tube babies were just making the scene here. It was kind of a new thing. There's a whole article on the new science of conception. It's kind of interesting. Oh, here's actually, I got this picture way back in 2004 from USA Today. America's first test tube baby, all grown up. Elizabeth Carr, she was 22 when this was taken back in 2004. There are a lot of them running around. Like I said, there are students here at Jeff who are test tube babies. I've got some good friends who just had a baby, 3 years ago. And he's a former genetics student. He's back there in one of those pictures. I think fall 2002. And he and his wife had a baby like 3 years ago. They were having trouble getting pregnant, and they went through this procedure, in vitro fertilization, test tube baby technique, and that's how they got their baby. So it's getting to be not a huge deal.
That's what my mom did, the in vitro, and it has my initials. Isn't that crazy?
What are your initials?
VF.
Your mom did that?
Yeah.
Awesome. You're a test tube baby.
Yes, I am.
How exciting. That's cool. Wow. Awesome. I'm so thankful you're here. Are you thankful you're here?
Very thankful.
We're going to find out how you got born. Yeah. You want to hear something that just blew me away when I learned about this? Okay, you got to check this out. I could not believe this. In fact, I have to have a meeting with these people. I've got it on my calendar. I don't remember when. Employees of the Lafayette School Corporation have health insurance, right, since we're employees. And there's a special little extra health insurance policy that you can get if you want to pay for it, to get tacked onto your health insurance. It's called Section 125. And this is a brochure on it, okay? And it's an extra policy you can purchase if you want to, like if you're a teacher in LSC or an administrator. And I was looking at the things that are covered by this little extra insurance policy. Listen to this list of things that can be covered if you purchase this policy. Acupuncture, alcohol and drug rehab,
What teacher needs that?
anesthesiologist, artificial limbs and teeth, that might come in handy, birth control pills, chiropractor, dental care, eye exam, eyeglasses, contact lenses, and so on, hearing aids and batteries, that could come in handy, insulin, and I've got this one circled with an exclamation point because I couldn't believe it, in vitro fertilization. And the reason I got really interested when I saw this is not all insurance policies will cover in vitro fertilization, and some people have to, when they do that, they have to pay out of pocket, and it can be like $20,000 to $30,000 a try. And if you're unsuccessful and you don't get pregnant, you still have to pay that bill. Yeah, it's expensive. And so I thought, well, this is really, how interesting is that?
I mean, but then again, most insurance policies don't give you acupuncture.
Right, yeah. So this is a pretty good deal. Now, I'm not interested in vitro fertilization, okay? We already have our kids. So I'm past that. Midwife, optometrist, pediatrician, physical therapy, prescription drugs, only those requiring a prescription by a doctor, psychiatrist, psychologist, stop smoking program, weight loss program for obesity. Well, listen to some of the things that are not covered. These are not covered. I'm thinking, bummer. Bleaching or teeth whitening.
Please.
Cosmetic procedures. Oh, there goes that liposuction I needed. Dancing or swimming lessons. Hair loss. I won't read all of them. And vacuum cleaners, it says. Why would you need a vacuum cleaner, you think?
Clean out your t-shirts.
Well, no, some people are allergic to dust mites, and they might. No, it's there. You want to read it?
Well, I suppose I'll get my brochure soon.
You'll get yours. Yeah. Yeah, it's real.
At home liposuction, do it yourself.
Yeah, I couldn't believe that. I thought it was incredible. Me too. So anyway, I just thought that was really kind of interesting. Now, I took this picture back in the early days when in vitro fertilization was just getting started.
Excuse the interruption. The person that was driving a black GMC Jimmy and has it parked out front, you need to move it immediately. The buses could not get in. Thank you.
See you in 10 minutes, Mr. Ruhl.
Yes, sir. All right. This is a picture I took out of the Lafayette Journal and Courier back in the day. Back in the 80s when test tube babies were just getting going. Is there anything about that picture that looks just maybe a little misleading? Baby, yes. Baby in a petri dish?
Be killing it. I don't think you can survive in there.
No, you can't.
I'm sorry, it's.
When they do this, okay, they take that egg from mom that's no bigger than a pencil dot on your paper. It's in a petri dish with nutrient solution. They add dad's sperm cells to the dish. The only thing that happens outside the body is fertilization. And like the first 3 or 4 or 5 days of early embryo development. And then when that little ball of cells, that early 5-day embryo, it's still microscopic. Then they put it back up into mama's uterus and hope that it will attach the normal, natural way. So the only thing that's happening outside the body in vitro is the fertilization. Okay? So, yeah, that's just a little misleading. Just a little. Howard and Georgina Jones, they started, it's a married couple, they're both doctors. They started one of the very first in vitro clinics back in the day, in the 80s, in Norfolk, Virginia. And there they are holding a couple of their success stories. And so, basic idea. Veronica, you may remember this. They pump mama full of hormones. Poor mom, she has to go through a lot with this. They inject her with hormones so that that particular month she'll ovulate not just one egg, but several. And they collect them. They collect them all, put them in a petri dish with nutrient solution, add dad's sperm cells. Mom has to undergo almost, well, it's easier now, but it's a surgical procedure to remove those eggs. All dad has to do is he goes into a waiting room and the nurse says, here's a cup, we need a sperm sample in a half hour. You had your hand up. Did you have? Oh, I'm sorry. Yeah.
What if all of those several eggs turn into babies?
Excellent.
The family doesn't want more than 2.
Excellent question. Okay. What if they collect 5 or 6 eggs in the petri dish? They don't want 5 or 6 babies in the uterus, because the more babies you have in the uterus, the riskier that pregnancy is, right? So what they'll do is they'll add the sperm cells and then they'll watch those eggs in the petri dish. If they all end up getting fertilized and they all start developing, they will likely put maybe 2 into mom's uterus. Put 2 in. and take the others and freeze them in liquid nitrogen, because they can do that, and then thaw them out and they'll be okay. And if it didn't work the first time, then they'll go back, thaw out the leftover embryos, and then try to transplant those back up into the uterus. That's what they do. Diana?
I remember what I was gonna say. Why would people want to do this? Like, what does it do?
Great question. Man, you guys ask good question. Why would anybody do this? There are several reasons.
Like, how is it more effective than?
Okay, the main reason some people will do this is sometimes the woman will have scar tissue on the inside of her fallopian tube, or scar tissue on the inside lining of the uterus. There's a condition called endometriosis, and some women have that. It's not uncommon. Some women have that, and it causes, and it's not fair, but more severe cramps than other women have, and it can create some scar tissue on the inside lining of the uterus, or maybe even in the fallopian tubes, to the point where you could have fallopian tubes that are blocked. You may have a blockage in the tube. Now, the tube's real narrow to begin with. Okay? Remember how big that egg is? Pencil dot? The diameter of the fallopian tube is not much more than that. And so it doesn't take much for it to get blocked. Say what?
I was telling the doc, you can't do it. If you're over 35, you can see it. Again,
Oh, that's right. That's right. But if you have a blockage in the tube, maybe this tube's blocked, that tube over there is blocked, then can you see how the egg wouldn't be able to get through and sperm would not be able to get to the egg? That's the main reason why people will resort to in vitro fertilization, blocked fallopian tubes. I'm not going to ask, was that your mom's deal? But I'm not going to ask. But that's the main reason. Okay? So they simply remove the eggs. Remember, they pump her full of hormones so that she gets ready to ovulate not one egg that month, but several. And they go in and they remove those eggs, collect them in the petri dish, and fertilize them in the dish, so they're bypassing the blockage, and then they squirt them back up into the uterus and hope that they attach the way they're supposed to. Yeah. Yep, that's how it works. Now here's how they used to collect the eggs in the early days. Mom had to be under total anesthesia, totally knocked out. And they would insert into the abdomen this thing called a laparoscope. It's got like an eyepiece on the end, a little flashlight on this end. Okay? Fiber optics inside. That's so they can look through here and scope around in here, find the ovaries. They also would pump gas into the abdomen and blow the abdomen up, sort of like a Lucas Oil Stadium effect, you know, so they have room to work in there. And then they would find the ovaries, and then they'd have another, like a thin, flexible plastic tube inserted in here with a needle on the end of it. And then they would take that needle and puncture the follicles and suck out the egg cells, and then suck them out and collect them in the petri dish. And that's how they would collect them. That was called harvesting the eggs. They don't do it that way now. You know how they do it now? Mom doesn't have to be put totally under anesthesia now. Now what they do is they'll go up with a hypodermic long needle syringe up into the vagina and take that needle through the wall of the vagina up directly to the ovary, and with that syringe, long needle, suction those eggs out. Gabby?
Can they choose to be under anesthetics?
Can they do what?
Can they choose to be under complete anesthetics, or?
Well, anytime you go under total anesthesia, there's a little risk involved. Yeah, there's a little risk. And so they don't do that but they numb everything. Everything's numbed. Yeah, they numb everything. Have any of you ever had any kind of a minor surgery where they didn't totally put you to sleep, but they made that part of your body like totally numb and you absolutely could not feel a thing?
Yeah.
Yeah. I remember one time I had to have surgery on my hand, or on. It was not when the iguana took the finger off. That was something else. That was total. That was total anesthesia.
I don't remember.
Wait, did you actually lose a finger?
I didn't lose it, but it was like practically off.
I don't think you told us that.
No, yes,
Oh,
I did.
that's
I
another
feel like that's
story.
a bio story you told us.
That's another story, another
Okay,
time.
you can leave, Mario.
No, I'm talking about a case where I had to have. Where was it? Oh, I had to have a little cyst removed from my knuckle. But it was really weird. They called it surgery, but they didn't put me to sleep. But the doctors all gowned up and the nurses all gowned up and I'm gowned up and I'm thinking, wait a minute, I thought this was just a routine kind of thing. And I'm laying on the table and I'm talking to the doctor while he's removing this cyst from my knuckle. And so, I mean, I couldn't feel my arm at all. And he's doing this, surgery. That's what I'm talking about. That's kind of what it's like if you have this done. You can't feel a thing. Not a thing. Okay.
Trust issues. What surgery? What surgery did you have like? It was my freshman year, 4 years ago. You missed a day. You gotta watch the pregnancy video.
I think it was on your knee.
Oh, I had knee replacement.
There you go.
Yeah. That's why I've got to tell them when I go through an airport. That's artificial.
I have it right
In your car?
Yeah. Cool. Yeah. I have a whole skeleton.
Oh my gosh. Wow. That's cool. All right. Okay, so Gabby, this is what it looks like. Now, Gabby, she can't feel a thing. The needle comes in here, punctures the follicle. There's liquid in that follicle, so pressure is built up, and they just suction the egg right out of there. Collect 5 or 6. Now, it gets to be a little bit of a bioethical decision for the parents and the people involved doing the work. If you've got like 5 or 6 eggs, the question becomes, how many do you put back in the uterus? Yeah, and which ones? Which ones do you freeze? If you only put 1 in, it might not work. Then mom's got to go through that entire thing again. Well, at least not the surgery, but the procedure. And they got to thaw them out, put them back into her uterus. But if you put more than 1 in, it's possible they might all develop. And then you have multiple births in there, which is kind of risky. So it gets to be a little bit of a bioethical. I'll tell you a real bioethical issue. Right now there are lots of embryos in limbo. They're in frozen storage in vitro clinics all over the country. There's now close to 500 in vitro fertilization clinics in the country. And there are a lot of frozen embryos in limbo that are left over. The parents got their babies, they were happy, they left, and they've abandoned and left these frozen embryos in frozen storage in clinics all over the country. And so what's the legal status of these frozen embryos that have been left behind? Nobody wants them. That's kind of a bioethical.
Couldn't you could you give it to someone else who was it? Like,
could you give
maybe
them?
like someone who's infertile, like can't like.
That's a possibility. But sadly, most people want their own. Not everybody.
Can't have their own.
Right. Yeah.
Do they give those embryos away to I can't think of what it's called, but when it doesn't turn into a baby, but you take those new cells, the stem cells, can they give those embryos away to science to use in this stem
Nowadays they're doing that.
Yeah.
To get the embryonic stem cells from them, but when you get embryonic stem cells out of an embryo, that destroys the embryo.
Yeah.
which is another bioethical issue. It's interesting, embryonic stem cells, we're going to learn all about embryonic stem cells later. They first became available during George W. Bush's administration. Okay, that's at the conservative end. To the right, George Bush cut off the funding for embryonic stem cell research because embryos were being destroyed to get the cells. Then during the Obama administration, well, now you're moving to the left, President Obama loosened up the restrictions on being able to use embryonic stem cells. I'm not sure where they're at right now. I'm not sure where I'm not sure right now. So it's an ever-changing thing as far as the laws. It determines what you can do with embryonic stem cells. Isaac, I think you had your hand up.
I did, but I totally forgot what I was going to say.
I'm sorry. Okay. Maybe it'll come back to you.
Oh, wait.
Yeah. Go ahead.
Can you give the embryo to like someone else? Like, what's that?
You could.
Isn't this just like isn't that like a whole other process of like fertilization?
I can stop copying you.
Ouch.
Wait, you mean produce an embryo by in vitro fertilization and then give that embryo to somebody else?
Yes. Like, because they're just there.
Just chilling.
Literally.
How long can this
How long can this last? Indefinitely?
In frozen storage? As far as we know, indefinitely.
I have one last question.
Yeah.
Okay, this could be really dumb, but like, why does like freezing them keep them alive? Like, I don't get that.
Because all the metabolic processes in the cells are just stopped.
When you say it's because ice crystals don't form,
Well, they freeze them in liquid nitrogen, which freezes them super cold, super fast.
So it's just
so ice crystals don't have time to form.
You can't do it.
And so that's why if you tried to freeze them in a regular freezer, it would kill them because the ice crystals form and they puncture the cell membranes.
Because I know I use DMSO, I think, to clean them. Would they do that for like baby cells?
I don't
clean
know.
Them because they said that's really like dangerous.
Yeah, I don't.
Past a certain point.
I doubt it, but I don't know for sure. I'm not giving you a complete recipe for in vitro fertilization, so you can go and do this on your own. Okay, this is basics here. Yeah.
Can humans be frozen in nitrogen?
Great question. Can a whole human person be frozen? Yes. Can the person be thawed out and survive? No. Okay.
Not yet.
Right. Not yet.
So when did they die? When did they die, technically speaking? Like
When they're frozen.
So they're dead after they're frozen?
Yeah.
Not when they're thawed.
Right.
Oh, dang it.
But now,
wait. So if anything isn't real.
Now you guys, the reason you can't freeze and thaw a human and expect them to survive is because a human being is, a full-grown human is a lot more complex than a tiny 6-day embryo. Okay? All right, moving right along. One more thing. Yes.
So there might be someone 5,000 years from now being born and said, well, in 2018, they didn't know what to do with you.
Right, yeah, that's right. All right, now guys, looky here before we leave. I'm anticipating they might break in and think we're done over the announcements. I'm hoping not. This is an actual photograph in an IVF clinic of a petri dish. They really ought to call these petri dish babies not test tube babies. With a pipette, this little droplet right here has about a half a dozen eggs in it. Human egg cells. And here's another view of, here's a technician examining these eggs under the microscope. Now the question that I have for you guys, I want you to think about here, is she's watching those eggs that have been extracted from an ovary, and she's trying to decide when it is time to add the sperm cells to the dish. Remember this picture here?
Yes.
Yeah. once they get to, so she sees 3 4 bodies, like 2 before she moves.
No, you're on the right track. That's not right.
When she sees one.
As soon as she sees those eggs give off a polar body, then she knows that they have completed meiosis 1 and they've become secondary oocytes with a little clinging polar body. That's when the egg is most fertile, most viable, most capable of accepting a sperm cell. In the body, when does meiosis 1 happen? Under natural conditions. Right, ovulation. So that's why people who are trying to get pregnant, they'll time sexual intercourse so that it happens around the time of ovulation. Because as soon as the egg breaks out of the ovary, that primary oocyte breaks out of the ovary, completes meiosis 1, kicks out a polar body, that's when that egg is most viable. So she's going to watch, and as soon as those primary oocytes in the dish kick out a polar body, she knows they've done meiosis 1. That's when the message goes down to dad in a waiting room. We need a sperm sample.
How long will that take? How long does she usually have to watch it?
Oh, I don't know. It's hours.
Does she have to stay there the entire time?
Well, no, they come back, go get a cup of coffee, and chat around the water cooler, come back and look. They kind of have an idea what's going to happen. Next question. When she's looking at those egg cells under the microscope, the sperms are so tiny, you can't really witness a sperm actually enter the egg. It's really hard to see. So how will she know? Okay, raise your hand if you think you know the answer. Don't shout it out. Raise your hand when you think you know the answer. How will she know if a sperm successfully penetrated the egg? Raise your hand when you think you know the answer. How will she know? What will she see that will tell her that, oh, a sperm got in there, got into the egg successfully? The hints on this page, right? Who wants to answer out loud in front of the world? Cole?
When there's 2 pronuclei.
Oh, they may be able to see. Okay. There's something that's a little easier than that. That's a good answer, but there's something a little easier to see than that. Okay?
Another polar body?
Another polar body. If the egg kicks out another polar body, then she'll know a sperm got in. Because when the sperm penetrates, remember, then that triggers the egg to do meiosis 2, kicks out another polar body. Sometimes that first polar body will go ahead and divide in 2, and she'll have either 2 or 3 polar bodies here, visible under the microscope.
Do you also see the zona hardening after the sperm?
Good question. The zona doesn't look a whole lot different when it hardens, so they don't really use that. They'll count the polar bodies. That's what they do. So these people who work in these IVF clinics, they have to know oogenesis, right? They do.
What about the little tails?
Oh, the tail breaks off?
Yeah.
Can't see it.
You just don't see like a little string just fly on.
No, those sperms are so small that even under those microscopes, there are going to be thousands of sperms all around the egg, okay? Almost impossible to see one go in. You got to look for that polar body coming out. So, look at this photo taken under a microscope in an in vitro fertilization clinic. What's the status of that egg right there?
Ready to go back.
Fertilized. There's 1, 2, 3 polar bodies, right? Make sense? So if you're going to work in a clinic like that, you need to know your polar bodies. You need to know all about that stuff. A lot of people don't realize that we're not going to watch that. A lot of people don't realize that down in Indianapolis, there are clinics down in Indianapolis that are well known nationally in the area of assisted reproductive technologies. So 70 miles away.
In Indy?
Yeah, oh gosh, yes. Indianapolis.
I feel like maybe like LA.
You'd be surprised. Indianapolis.
What's wrong with you?
Actually, Indianapolis is a leader, is one of the leaders in terms of human genetics. Down at Riley Hospital.
At Riley? Riley's a good hospital.
You have stuff from all over the world, probably.
Yeah, that's true. I think this is a good place to stop. We still have a few details on page 9 that I want to touch on before you go to those clinics in class on Monday. Okay? What's that?
It gets more and more. It's crazy.